Welcome back. Now we will discuss about the combustion chambers. So the design of the combustion chamber plays an important role in a combustion process. So this combustion chamber should be designed in a such a way that it reduces the abnormal combustion tendency or detonation in SI engine. So for that purpose, while designing this combustion chamber, we must note some important points, that is shape of this combustion chamber must be hemispherical. So due to this hemispherical shape, what happens? The flame traveling distance is low, and as the flame traveling distance is low, there is a less tendency of detonation or abnormal combustion. So next, material of this combustion chamber must have high conductivity. So whatever the material we have to select for this combustion chamber, that material should have a more conductivity. Next is absence of hot spots. While designing the combustion chamber, we must note the absence of hot spots. There is no any hot spots inside engine cylinder. If these hot spots are there, auto ignition of the charge takes place and abnormal combustion increases. So here are some different designs of these combustion chambers for SI engine. So in early days, so these types of combustion chambers are used in engine. So first one is T-head combustion chamber. So that combustion chamber is called as T-head because its shape is like letter T. If you see the diagram, its shape is like letter C. So what is the advantage or disadvantage of this T-head combustion chamber? So in T-head combustion chamber, the flame traveling distance is more. So in that combustion chamber, the abnormal combustion, that is detonation tendency, is more. Again, if we see the walls, inlet wall and outlet wall, so these walls are side-by walls, that is these walls are placed at both sides of this engine cylinder. So for this operating of this wall, separate camshaft or crank camshaft arrangement is required. So as there is a different camshaft arrangement, there is a more maintenance of this type of combustion chamber is there. Again, due to these side walls, so whatever the pumping loss of that engine cylinder, that pumping loss is more in T-head combustion chamber. So due to these drawbacks, nowadays these T-type or T-head combustion chambers are not in used. So next is L-head combustion chamber. If we see the diagram, L-head combustion chamber, its shape is like a letter L. So one drawback of this T-head combustion chamber is eliminated with the help of this L-head combustion chamber. So instead of these side walls, in L-head combustion chambers, the walls are placed at one side of the cylinder and side by, that is overlapping of the wall, takes place. So due to that, with the help of single crankshaft arrangement, we can operate these walls, but the flame traveling distance is more because its shape is like a letter L. So the flame traveling distance from nucleus of combustion towards end of combustion chamber is more. Again, in L-head combustion chamber, the pumping loss is more. So due to these drawbacks, again these L-head combustion chambers are not in use. So continuously there is improvement takes place. First one is T-head, after that L-head. Again, whatever the drawbacks of this T-head, L-head are eliminated by some scientist. And after that, the next is I-head combustion chamber. So in this combustion chamber, so shape of this combustion chamber is like I letter. So in this combustion chamber, whatever the side walls are there, these walls are placed over the head of the combustion chamber, that is overhead walls are there. So due to these overhead walls, the pumping loss decreases. But again, if you see the shape of this combustion chamber, that shape is somewhat like hemispherical shape. So due to that, the flame traveling distance reduces, and as the flame traveling distance reduces, the abnormal combustion tendency also decreases. So next is F-head combustion chamber. So why it is called as F-head? Because its shape is like F. Again, in this, flame traveling distance is mover, and as the flame traveling distance is mover, the detonation tendency or abnormal combustion tendency is mover. So for these types of combustion chambers, some drawbacks are always there. Due to that, these types of combustion chambers nowadays are not in use. So some modern combustion chambers are used nowadays because continuously there is improvement. That is, continuously there is a research to reduce the abnormal combustion and to increase this combustion phenomenon efficiency. So the modern combustion chamber, that the first one is Jaguar combustion chamber. So in this Jaguar combustion chamber, the combustion chamber shape is like a hemispherical shape, and both the walls, that is inlet wall and outlet wall, both are placed over the head of the combustion, that is overhead walls are there. So due to this, what happens? Due to hemispherical shape, if we locate the spark plug at center, the flame traveling distance is low. As the walls are overhead, pumping loss decreases. So it eliminates some amount abnormal combustion tendency of engine, that is Jaguar combustion chamber. Next is bathtub combustion chamber. So its shape is like a bathtub, that is a reverse bathtub. So again, in this combustion chamber, if we see the shape, that shape is some amount like hemispherical shape. Due to that, the flame traveling distance decreases and walls are overhead walls. So these are the modern combustion chambers in which whatever the important points to reduce this combustion, that is abnormal combustion tendency, that points are considered during the design, and that modern combustion chambers are in use. So this is about the combustion chambers in SI engine.